Hello everyone, so welcome to my course on Laplace transforms. Today we are going to see what is integration of transforms. That means when do you integrate the transforms. Okay, so for whose Laplace you have to integrate the Laplace transform. Okay, or in another words, what is Laplace of f of t upon t? Well, I can directly give you the formula, but just hold on a minute. Let me tell you how this is connected with what we have seen earlier. That means Laplace of integration. So if you recall my previous lecture, link is there in the description if you have missed that lecture. So what we have seen earlier, what is Laplace of integration? So we saw earlier, if f of t has a Laplace f of s, then if I do the integration in t space, so it is integration of 0 to t f of t tilde d of t tilde. Since here is a variable t, I am using the variable d tilde. So, or some people also use some another variable, they use sometimes f of tau d tau. So both is fine. So if you have a Laplace transform of a function and if I integrate that in the t space, then question is what is its Laplace, and we saw that the Laplace is nothing but in s space you simply divide by s to the original Laplace. So this is what we saw earlier. So if we are integrating in the t space, in the s space you are dividing by s to what? To the Laplace of the original function. Now question is, if I divide here in the t space, what will happen in the s space? Answer is integration. So what I want to say is, so if you are dividing your function by t, or if you are dividing a function by a variable in t space, then in s space you have to integrate it. So that's why this is called as a dual of this theorem. So here we saw what is the Laplace of integration. It is nothing but you have to divide. And here we are saying if I am dividing my function by t, then what is the Laplace? It is nothing but the integration. Therefore, integration of transpose is nothing but the dual of Laplace of derivative. Okay, so this is one thing which I always want my student to observe. Well, you can always learn the formulas and you can solve the problems, but to do this connection of duality is very much important. Okay, so this is what the formula is, and therefore what is f of t upon t? It is nothing but Laplace inverse of the integral in s space. So these are the two things which is important, and now let's see some examples that involves integration of transforms. Before taking the example, let me tell you one small point. Here question is when this Laplace exists. So like the one obvious thing is, I'm assuming that Laplace of f is f of s. So my f has to be a nice function. Nice as in it should satisfy the condition in existence theorem. What were the condition? Your f should be piecewise continuous and your f should be of exponential growth. Now but here since I'm dividing by a variable in my t space, there is one more condition for this Laplace to exist. And that condition is, when I approach 0 from right hand side, this thing should exist, and if this does not exist, then the Laplace does not exist. Okay, so this is one important thing which people usually forget. Limit of t goes to 0 of this should exist, then only this is valid. So for example, if I ask you what is Laplace of e raised to t upon t, whether this Laplace exists, answer is no. Why? Though my f is of exponential growth and piecewise continuous, but when I take this ratio, its limit as t goes to 0 should exist. Does it exist? No. As t goes to 0, this part is 1 and this is 0. So you have 1 upon 0 which is infinite, which does not exist. Therefore Laplace of e raised to t upon t does not exist. Or in short, Laplace of e raised to at, let's generalize, upon t does not exist. What about Laplace of e raised to at upon t square? Or t cube, or upon t raised to n? Does this exist? Tell me your answer in the comment section. Okay, now let's go to some nice examples where the Laplace of such kind do exist. Now, what is Laplace inverse of ln of s plus 1 upon s minus 2? Okay, so let me call this, suppose f of t. Suppose the Laplace inverse of this quantity is f of t. So if I take my Laplace inverse over there, so I want to find a function whose Laplace is this quantity. That means what? Laplace of f of t is what? Ln of s plus 1 minus ln of s minus 2. Okay, now ln came into picture. When does ln came? When you take integration. What is integration of 1 upon x? Ln of x, right? So some kind of integration derivative should come into the picture. Okay, so now if I take what is Laplace of t f of t, I know Laplace of f is this, so I can easily find what is Laplace of t f of t by my previous lecture on derivative of transforms. So what is this? This is nothing but minus of this derivative. Okay, so if Laplace of f is capital F of s, then Laplace of t f of t is nothing but minus f dash of s. And here if I do that, What is derivative of this? So I have minus of 1 upon s plus 1 minus 1 upon s minus 2. Now if I take this minus inside, what do we get? We have 1 upon s minus 2 minus 1 upon s plus 1. So what is my t f of t? It is nothing but the Laplace inverse of the right hand side. Then what is Laplace inverse of this? It is e raised to 2t minus e raised to minus t. And therefore what is your function? Your f of t is nothing but So this is how you solve a problem if you have ln into the picture. So Laplace of this quantity something upon t is nothing but the given what was there in the question. So I hope this example is clear. If yes, let me give you one homework problem. Tell me the answer in the comment section for this question. Laplace inverse of ln of s upon s plus 1. Actually, let's generalize this. You also tell me what is Laplace inverse of ln of s minus a upon s minus b. If you see my previous example, your a was minus 1 and b was 2. S plus 1 upon s minus 2. So your a was minus 1, b was 2. And those minus 1 and 2 were coming into the solution. Here your a is 0, b is minus 1. You solve this, e raised to 0 means 1 will be there in the solution and your b is minus 1. So e raised to minus t will also come into the solution. So ultimately what I guess answer for this is e raised to bt minus e raised to at whole divided by t. I am repeating, e raised to bt minus e raised to at whole divided by t. This is what I guess. Your job is to find out and comment your answer in the comment section. And if you understood this lecture, do not forget to like, share and subscribe. Thank you.